All right, let's do this. This basically is your second packet, and these are requirements. The class is geometry, but these are requirements. You need to be able to master this, or if you haven't already done so. So let's start with the first few problems. So as you can see, this is an expression. It's not an equation because it doesn't have an equal sign. So what do I do here? Well, they are asking me to multiply this number. Always remember the sign to the left of the number because you gotta use it. Okay, and there are two ways in which you can multiply this. So the 4 is nothing more than adding to this. Okay, so it's not really multiplying. So the 4 remains the same. See that? Let me see if we can do a little more. Yes. Okay, so the 4 is right there. Now let's start the multiplication. Negative 2 times 13 is negative 26, right? So we do minus 26, okay? And then distributive property. Now negative 2 times positive 11, okay? So negative times positive is negative. In this case, minus, right? 2 times 11 is 22. Don't forget the m. And then you go ahead and you add the like terms. So what is 4 minus 26? Negative 22. So we have negative 22 minus 22m. I cannot combine them because they're not like terms. We already discussed that on the previous lesson. All right, and just a reminder, this is lesson number 2, okay? But these are the requirements. All right, that's it. So now let's do problem number 2. Negative 19 times 2 minus 5w. So what is negative 19 times 2? Is negative 38. And then negative 19 times negative 5w, in other words, negative times negative is positive. 19 times 5 is what? There you go, yes, 95. 95w, okay? And then look, you can't add them because they're not like terms, so that's it. Like terms have, if they were like terms, either this doesn't have a w or this would have a w. All right, let's go on to number 3. Once again, negative 9, there is no sign between the 9 and the parentheses, so that's a multiplication. Look, the 13 has nothing to do with it. So then we're gonna start multiplying. So we multiply negative 9 times negative 18, right? So that is positive 162c. Then negative 9 times positive 12. So negative 9 times 12. What is negative 9 times 12? Is 108. And then you bring down the negative 13. In this case, when the number is by itself, it's called negative. When it's between numbers, is a minus. Okay? All right, cool. Now let's go ahead and add the like terms. So we have negative 108, okay, minus 13. So that is negative 121. And then of course plus, because this 162c is positive, so plus 162c. Now you could write it like this if you wanted to. 162c minus 121. Okay, let's move on to the next one. Okay, so remember something, you always try to do this on your own. You pause the video and you try to do it on your own, and then if you're unsure or you want to check, then you continue. All right, so here, negative 14w has nothing to do with this expression right here. The 7 is the one that is multiplying it. So let's see, positive times positive, positive. 7 times 13 is what? Very good, 91. And then again, I multiplied here, now I gotta multiply over here. So positive times negative is negative. 7 times 2 is 14. 14 what? 14w, because you have the w right here. Okay? And now we add the like terms. These are like terms. Look, negative 14w and negative 14w. Never forgetting the sign. So that's negative 28w plus 91. Let's move on. Okay. So here, once again, we have a multiplication of the 7, but we don't have a multiplication of the negative 16r, right? So then let's start doing it. like terms. Alrighty, let's move on. Positive times negative, negative. 12 times 8 is okay, and that's it. I cannot do anything else because they're not like terms. Alright, here it's a different story. Here we have a binomial, 1, 2, multiplied by another binomial. So there are two ways of multiplying this. The long way, which is you start distributing. You get the first term here and you multiply by everything inside this parenthesis. So for example, x times x is x squared. X times negative 1 is negative 1x. Okay? Then I'm done. You see, I finished multiplying by everything here. Now I go with the 1. 1 times x is positive 1x. 1, okay? And then 1 times negative 1 is negative 1. Then you proceed to add the like terms. Now negative 1x plus 1x, they cancel out, because it's like saying 1x minus 1x. Okay? Opposites cancel out. So you end up with x squared minus 1. Now let me show you a shortcut, okay? So it only works when you have binomials. So for example, you already know that these two are going to give you the first term. And you know that the multiplication here is going to give you the last term. See that? Now, the problem is, how do I get the middle term? Easy. Do a smiley face. Okay, connect the extremes and connect the middles. And see what you get. Here you get 3 times a is 3a. And here you get 4a. So then what do you have? 7a. Positive 7a. Right? Yes. Okay then. Now, here, it's a different story. You have to do the whole process because it's not a binomial against a binomial. It's a binomial against a trinomial. So you gotta do it. So take this term, right? And we're gonna multiply by everything inside this parenthesis. Okay then. So let's see now. X times x squared is x to the third power. Because when you multiply powers of the same base, you add the exponents. This is nothing more than an x to the first power. But we don't write it because it's implied. So we have x to the third power, okay? And now x times 2x is 2x squared. Then x times 1 is 1x. And notice I always keep check of the sign. Alright, I'm done with this. Now I'm gonna start with the 1. Okay? So 1 times x squared is positive 1x squared. Okay? Then 1 times 2x is, well, anything times 1 is itself, so 1 times 2x is 2x. And 1 times 1 is 1. Okay? And now we add the like terms. Well, x to the third power doesn't have like terms. 2x squared goes with x squared. So if you have 2x squared and you add one more x squared, you have 3x squared. Okay? And now x and 2x. That's 3x's. And of course, plus 1. Damn, the mosquitoes are biting me. What did I do? Sweet blood. Anyway. Oh, okay. Here, it's something that you also need to keep in mind. So when you have the same expression squared, well, x times x is x squared. So x plus 4 squared should be x plus 4 times x plus 4. See that? And that's about it. And then since this is a binomial multiplied by another binomial, you just multiply using the distributive property or using the smiley face. You already know that this is going to be x squared. Okay? You already know that the last term is going to be 16. Okay? And now to get the middle term, you just do a smiley face. Okay? So what do we have here? 4x, and here 4x. That's a total of 8x. Oh, and the 16 was positive. All right. Now there's a trick to this. If you have a binomial that is being squared, all you have to do is follow the following. Sorry. Square the first term. Now multiply the two terms here, so that's 4x, and double it. So 4x times 2 is 8x. Boom. And then square the last term. Okay? Now let's move on to the next one. All right, let's do this one using the shortcut. So it says square the first term. Multiply the two terms. So negative 3 times x is negative 3x. And double that. What is the double of negative 3x? Is negative 6x. And then negative 3 squared is positive 9. See that? Okay. Okay. So let's move on to the next one. So we have this square. The same process applies. Okay. So let us do it both ways. Let us do the long way. So this is 2y minus 1 times 2y minus 1. So far so good. Yes. Okay. And now let us use the distributive property. So 2y times 2y is 4y squared. Then 2y times negative 1 is negative 2y. I'm done with this. Now I'm gonna use this number. Okay. So negative 1 times 2y is negative 2y. Negative 1 times negative 1 is positive 1. And now I add the like terms. Negative 2y and negative 2y, that makes negative 4y. And then this one doesn't have a like term. Now let's see if it would have worked using the shortcut. So let's see. Square the first term. So 2y squared, 2y, the whole thing squared gives you 4y squared. Now when you put this together, negative 1 times 2y is negative 2y. And you double that, you get negative 4y. And then you square these terms. So negative 1 squared is positive 1. And that's it. That's about it. It's not difficult. Just gotta make sure that you understand. All right then. So let us move on to the real lesson, which is lesson number 2. So here we go. I'm in the process of creating a video called 100 linear equations, okay? And you guys are going to, you will have access pretty soon to the whole thing. Right now I just did the first part. All right, so here we are going to use the writing process to solve linear equations. So we are going to answer a couple of questions right here. The first one, okay, being, what is the identity element of addition? If you remember, I explained it on the last lesson. The identity element of addition is 0, because anything plus 0 is itself. Now let's try the second question. The identity element of multiplication is, right, you guessed it, because anything times 1 is itself. Once again, let's go here. The additive inverse of any number is its opposite. The multiplicative inverse or reciprocal of a number is found by flipping the fraction. True or false? Gucci. All right. And now here you have the laws. I call them the laws for solving linear equations. The first thing you have to do is you gotta look out for any distributive property, as I explained on the previous video. Then you have to ask yourself, are there any fractions? Because if there are, you need to multiply the whole equation by the common denominator. Then we have, are there any like terms on the same side of the equation? I made this rule, so you have to abide by it. Okay? Just because you could see like terms on both sides, but that doesn't mean that it applies to this rule. It says, are there any like terms on the same side of the equation? If there are, please combine them. Are there variables on both sides? If there are, use the additive inverse of that variable to get rid of it. My suggestion is get rid of the lesser value, okay? It's always going to be helpful. Then number 5 says, use the additive inverse, okay? And it explains to you, usually there is a plus or minus between the variable and the number, like that you, the plus or minus between the variable and a number, okay? So for example here, you would use the additive inverse of 4 because there is the plus between the variable and the 4. So you would subtract 4, okay? Then last but not least, it says use the multiplicative inverse, okay? If there is a number that is multiplying or dividing the variable. So it usually looks like this. 3 is multiplying x. So you would use the multiplicative inverse of 3, which is 1 over 3. 4 is multiplying y. 7 is multiplying b. So you would use the multiplicative inverse of 7 or reciprocal of 7. This is 7 over 1. So the reciprocal will be 1 over 7. Okay? Anyway, let's get cooking because I really need to get to this. All right. Here we go. Here you have your first OD equation. So what am I going to do? Well, to solve it. So I'm going to ask myself, do I have distributive property? That's the first thing. And I definitely do. So I'm going to use my distributive property. So negative 3 times 4 is negative 3 times 4x is negative 12x. Okay? Then negative 3 times positive 3 is negative 9. Okay, I'm done with this distributive property, but look, there could be more than one expression that involves the use of the distributive property. So for example, 4 times 6x is positive 24x. Then you have 4 times positive 1, which is positive 4. So I'm done with the distributive property, and then I just bring down whatever was left. Okay. Then the next rule was, are there any fractions? The answer is no. So we don't need to find any common denominator. The third rule is like terms on the same side of the equation. Just remember that. So let's see. 12x goes with, look, I made a mistake over here. Hopefully you corrected me. This 24 comes from 4 times 6x. So this should be 24x. Okay, cool then. So now I know negative 12x and 24x. 24x minus 12x or negative 12x plus 24x, it's still the same thing. So when I combine them, 24 minus 12 is 12. So it's 12x. Now, negative 9 goes with positive 4. So that should give me a negative 5. And then I bring down the equal sign and then the suggested answer, which is 43. Now I go with, are there variables on both sides? No. Okay. Then use the additive inverse. Of what? Of the number that is either adding or subtracting the expression with the variable. In this case, there's a minus sign between the variable and the number. This is mechanic, but if you can make sense of this, it's a lot easier and a lot more helpful. All right, so 12x, and remember, don't be trying to add 5 here and then 5 here. You do whatever you do to one side, you do to the other, not to the same side. All right, so negative 5 and positive 5, the idea is to cancel them out. So we're good with that. Bring down the equal sign, and 43 plus 5 is 48. And now, I know. Right now, we're gonna use the multiplicative inverse. Later on, you could just divide by it. I know what you're gonna say, just divide by 12 on both sides and it's over. Yeah, I know. But you need to understand why. So, 12 is multiplying x. So I know that I have to use the multiplicative inverse or reciprocal of the number. This is the same thing as 12 over 1. So the reciprocal should be 1 over 12. And now we multiply. 12x times 1 is 12x. So I get 12x over 12. Okay? If you want me to put the 1 under it, I'll do it. So you can understand that this is 12x times 1 and this is 1 times 12. But it's the same thing. When you multiply by a fraction, you multiply by the top, and if there's nothing here, you divide by the bottom. All right. Now 48 divided by 12. And my answer is, okay, 4. And that's how you solve equations. That's not a problem. All right. So what do we mean by consecutive integers? Well, hello, consecutive integers. Consecutive integers are 1, 2, 3, 4, all the way to infinity, one after the other. Now, when we are talking about algebra and we don't know what the first number is, we always start with x. So x is the first number. Now, if x is 1, how do I get from 1 to 2? You add 1, so the next number is x plus 1. The next number is x plus 2, x plus 3, and so on and so forth, all the way to x plus infinity. Correct? Okay, example of consecutive even integers. Well, what are even integers? 2, 4, 6, 8, 10. You get the idea, all the way to infinity. So, if you don't know, then you write x. Now, from 2 to 4, how many do I add? 2, right? So then the next number is x plus 2. Then from 2 to 6, I add 4. So the next number is x plus 4. From 2 to 8, I add 6. So the next number is x plus 6. So on and so forth, all the way to infinity. Okay? Now, give examples of consecutive odd integers. Odd numbers is 1, 3, 5, 7, 9, okay, and so on and so forth, all the way to infinity. Now, when you don't know, you write x, right? Okay then. Now this might seem confusing, but then these numbers that I'm writing is the gap between each number, okay? Just in case you think that I'm writing the same thing, which eventually I am. Okay, so how do you go from 1 to 3? Well, you add 2, right? So the next number is going to be x plus 2. How do you go from 1 to 5? You add 4, so the next number is x plus 4. Then x plus 6. Now look at this. This looks exactly like the same as the even numbers. Of course, because this is nothing more than the gap between numbers. They go by 2s. Well, guess what? The odd numbers also go by 2s. So don't let this misguide you. All right? Let's move on then. And here we go. Solving equations. So let's see how many I do here. Okay. I am not going to be writing down all the steps all the time because that's really obnoxious, but I'll try at least to mention them. All right, so here, do I have distributive property? And you say yes or no. Of course not. Do I have fractions? No. Do I have like terms? Whoop, hold your horses. These right here might be like terms in a general way, but for the purposes being, my rule says, are there any like terms on the same side of the equation? No. No. Okay. Then my next rule is going to take care of that little thing. Are there variables on both sides? Yes. So then get rid of the lesser one by using the additive inverse. You see that? So I put 2g on both sides. And now bring down the 3, okay, because nothing is happening to that. Now these two will cancel out because they're opposites. Then 5g minus 2g, hello, 5 gangsters minus 2 gangsters is 3 gangsters. And then minus 9. Okay, so where was I? Variables on both sides. Look, I did distributive property, I did fractions, which was no. Then I did like terms, then I did variables on both sides. Then I am gonna try to see if there is any additive inverse. And in fact, look, minus sign between the letter and a number, so I have to use the additive inverse of that number. What you do to one side, you do to the other, right here, not here, okay? 3 plus 9 is 12. And this, of course, becomes 0, so I don't need to write it down. Okay, so now what am I gonna do? I am going to use the multiplicative inverse of 3, which is 1 over 3. And if you see the other videos, you'll understand that the idea is that you're gonna end up divided by 3, but I'm gonna do it right now. So this is 3 over 1, so the reciprocal is 1 over 3. I just need you to become acquainted with that. Okay, so now what happens? 1 times 12 is 12 over 3. I'm gonna write it down. Later on, I'm not. I'm just gonna say it's 4. See that? And now 12 divided by 3 is 4. 3g divided by 3, well, 3 divided by 3 is 1. 1 what? 1g. Oh, wait. Okay, now I did. Cool then. All right, let's move on. Here. All right, column B. So it says solve negative 1/3 y equals 15. So, is there any distributive property? No. Are there any fractions? Yes. If there are fractions, then you need to use the to find the common denominator. And I hate those words. Okay, so let's see. What is the common denominator? Wait, hold on a second. There's only one denominator. Look, 15 has a 1 under it, but it's not gonna affect this. So 3 is the common denominator. So what you do is you multiply the whole thing by the common denominator. That's it. Okay, so 3 times negative 1 is negative 3 over 3. So that's negative 3 over 3 y, correct? And then equals 45. No, wait, yeah. 15 times 3 is, I was looking at this little one right here, but this one is from the 15. So 3 times 5, 15 is 45, so we're good. Now, negative 3 divided by 3 is basically negative 1. So I get negative 1y. Okay? And negative y becomes 45. Unfortunately, I can never have a variable being negative as an answer. So I am going to use my multiplication by negative or negative 1 if you want to. You can multiply by negative or negative 1. Okay? The idea is that when you multiply by negative 1, you change the sign of whatever you want. So here, anything times 1 is itself, so this becomes y. Negative times negative is positive. Here, positive times negative is negative. And 45 times 1 is 45. So multiplying by negative 1 just changes the sign, okay? Good, let's go to the next one. So let's ask ourselves, do I have distributive property? And the answer is, okay, do I have fractions? And the answer is, okay, do I have like terms on the same side of the equation? And the answer is, excellent. So then the next one is, do I have variables on both sides? See, now I'm skipping steps. If you're still not sure, then you need to write them all down, like distributive property, fractions, to see if yes or no, you have it or not. All right, variables on both sides, yes, 4x and 1x. I'm gonna get rid of the lesser one by either adding or subtracting. Bring down the 5. This already canceled out, it became 0. But since I have a 7, I bring the 7 down. Then the next rule says use the additive inverse if I have. Remember, additive inverse, there will be a minus or a plus between the letter and the number you want. Sorry, between the number and the letter you want. The letter is the one that you want. So I'm going to use the additive inverse. What you do to one side, you do to the other.
I won.
See that? And now, you do what? Multiplicative inverse of 3, right? Because 3 is the one that is multiplying the letter. So we have this, and we do multiplicative inverse of that. So now let's see. 3x times 1 is 3x over 3. So we have 3x over 3. Then this one is 12 times 1 is 12 over 3. So then 3x divided by 3 is just 1x. 12 divided by 3 is beautiful. Okay. Let us do the next one. Okay. Here, this is a proportion. Okay, it's called a proportion. You could just cross multiply and find out what the answer is. I am not going to cross multiply. That's up to you. I am just going to basically follow the rules to see if it can be solved by following the rules. But you know what? I want you to try it right now, okay? Take 1 minute and try it.
Stay in there. I'm not going to let anybody see you. There's a bluebird in my heart that wants to get out, but I have no whiskey on it.
Alright, so you did. Alright then, so my common denominator here, if you found out, was 24, because that's the only number that on the times tables that they meet, okay, that they have in common. So I'm going to multiply the whole thing by, wait, 24, no. What about 12? No, 12. Look, they got 12 in common. 4 times 3 is 12, and 6 times 2 is 12. So the common denominator is 12. Oh my God, thank God I made that correction, because otherwise I was going to go to 24 and forget it. All right then. So I'm going to multiply the whole equation by the common denominator. You already know what's going on. I could put a 1 under it, but it really doesn't matter. So 12 times negative 5 over 6. 12 times negative 5 divided by 6. I don't know what 12 times negative 5 is, but I know what 12 divided by 6 is. 12 divided by 6 is 2. 2 times negative 5 is negative 10. You put the x equals. Now, I don't want to multiply first. I want to divide first. So 12 divided by 4 is 3 times 3 is 9. And now, I'm going to use the multiplicative inverse. But, just, for a couple of times. The idea, the multiplicative inverse, the only thing that is going to do is going to make me end up with 10 over negative 10 and 9 over negative 10. Or as you would say, just divide by negative 10 on both sides and that's it. Well, you're right. Negative divided by negative is positive. So x equals 9 over negative 10. Another way of writing that is x equals to negative, and then you see, negative 9 over 10. Put the sign in the middle to denote that the whole answer or the whole fraction is negative. All right then. So now I want you to try the followings, okay? So right here, I'm telling you right now, I know there's no DP, there is no fractions, there's nothing like that. I can already skip to like terms. So 2x plus 3x, 5x, minus 7x is negative 2x. And also using my common sense, I don't need to divide by negative 2 on both sides. Remember, we're taking the easy way, but in reality you have to use the multiplicative inverse, which is negative 1 over 2. But anyways, so negative 2 times what is negative 10? Negative 2 times 5. So negative divided by negative is positive, and 10 divided by 2 is 5, and bada bing bada bam, you're done with that. Okay, so here, here we have fractions. Okay, I'm not gonna start with the distributive property. I'm just gonna go directly to what we need. We need to find the common denominator. 2 fits into 6, 3 fits into 6, so my common denominator is already 6, okay? Because when we go on the times tables, they're all gonna have 6 in common. So I multiplied the whole thing by 6. Notice that the 6 should go on the top, because you're gonna multiply by the numerators and divide by the denominators. That's why. You never put the 6 in the bottom, because you're gonna make a huge mistake. So let's see now. 6 times 2 divided by 3. That's how you read it. Or 6 divided by 3 times 2. I'm saying the same thing. As I said before, I'd rather just divide first. So 6 divided by 3, 2. Times 2, 4. 6 divided by 2, 3. Times 1, 3. Keeping in mind the signs, okay? Positive times negative, positive times positive is positive. All right. Now, 6 divided by 6 is 1. Well, when you multiply and divide by the same number, they cancel out. It becomes 1. So 6 divided by 6 is 1, times 5 is 5. And look, now you have a beautiful equation without fractions. So now what am I going to do? I'm going to use the additive inverse. And now what am I going to do? I'm going to use the last rule is multiplicative inverse. Yes, the multiplicative inverse of 4 is 1 over 4, because this is 4 over 1. So that's what I'm going to do. Now when I multiply by 1 over 4, I end up with this, what you call, I just divide by 4 on both sides. So 4 divided by 4 is 1, 1x. 2 divided by 4, 2 is half of 4. So basically if I reduce it, I get 1/2. Right? Okay. Now, let's go on to the next one. Oh, okay. So here, once again, I have to come up with the minimum common multiple or the common denominator. So let's see if you can figure out what is my common denominator right here. Perfect. So I'm gonna multiply the whole thing by that common denominator, 15. And now, you know, I gotta use the distributive property again to like get rid of all the fractions. So remember what I said, I rather divide and then multiply than multiply and then divide, because it's easier for me. So 15 divided by 5 is 3 times 2x. Okay. Wait, what did I do? Why did I add 3? If you correct me, I'll give you 2 points. If you didn't, then too bad. Okay, we're good? Alright then. Here you go. Alright, so the first thing I'm going to do is I'm going to really get rid of the distributive property. If you have questions, ask, and I'll explain to you where I got these numbers. If you already know what steps I'm going to use or what properties or which of the rules I'm going to use, then please, you are more than welcome to shout them out. So I can give you some credit, okay? In classroom, of course, duh. And it's a good way for you to practice. Okay, you could be practicing by calling it out loud and see if you learn them or not. All right, then. So now that I use the distributive property, now I have fractions, so I'm gonna use the common denominator. So what is the common denominator? Beautiful. Okay. So here I go again. Oh my God, how many distributive properties am I gonna use? So let's see. 6 divided by 3 is 2 times 1 is 2, so 2k. I like the game. Awesome. Once again is 2 times 2, 4. Remember, when you multiply and divide by the same number, they cancel out in, of course, in division, right? Okay. And now, let me see, variables on both sides? Nope. So then I'm gonna skip to the additive inverse. And now, remember we're multiplying by 1/2. Cool then. Let's try the next one. But this time I want you to try it, okay? I don't want you to just copy off of me. I want you to really try it. If you can dictate to me what I'm doing, that's even awesomer. I don't know if that's a word, but yeah, it's more awesome. More better. And now, guys, I'm not going to do the whole process. I'm gonna skip 2 steps. So x equals to 44 over 5. If you still don't understand why, then fine, I'll explain. But that's the answer, right? Okay, so what do? I just want to see something. No, I mean, it looks like something I've done before. It's okay. So I'm done with the distributive property, and now common denominator is 5. So multiply the whole thing by 5. You could call it, say 5 divided by 5 is 1 times 3x is 3x. 5 divided by 5 is 1 plus 6, you know that. Alright, so I'm running out of space. And remember what I said in geometry, it's not how much work we show, but how accurate the work that we show is. So, okay, so I use the variables on both sides property here. I did it, and now here I'm gonna use the additive inverse of -20, which is +20. So I'm gonna end up with 26 equaling to 2x. Okay? Because by adding 20 here, I'm canceling it out. Now here, what am I gonna do? I'm gonna use the reciprocal or multiplicative inverse of 2, which is 1 over 2. Then that multiplication is going to result in a division by 2. In other words, divide by 2 on both sides. So then that should tell you that x is 13. Capiche? Good. Alright, let me see. We have a quiz. Okay, so this last problem is yours. Okay, please make sure that you do it accurately. We've done enough equations for you to be able to solve any type of linear equation accurately. Oh, of course, yeah, you also need this calculator. Okay, so we have like terms right here. Anyways, I really don't see, that's why I don't want to add 1/2 x and then -1/3 x. I'm just gonna use the second property, fractions. Look at this. As soon as I use the second property, you'll see what happens. So between 2 and 3, because that's all I have. What is the common denominator? 6, right? So just multiply the whole thing by 6. And now look how beautiful it comes out when you multiply by the common denominator. So 6 divided by 2 is 3, times 1 is 3. 6 divided by 2 is 3, times 1, 3. 6 divided by 3 is 2, times -1 is 2, okay. 6 divided by 3 is 2, times 2 is 4. Okay, now I can add like terms. Gosh, that's a lot easier. Beautiful, right? All right. So by now we should be gangster at solving linear equations with fraction or without fraction. Really doesn't matter. All right. Let us move on to see what's going on. Oh, guys. Okay. So you have to graph this function. That's not a problem. The first thing we do is, okay, since you guys don't have a calculator, you haven't gotten one, remember the model of the calculator, and I'm gonna write it down, is TI-84 plus CE. Okay, that's the calculator you need to get. All right, so let's see if I can help you with this quiz. Hopefully you know how to plot points. So graph the following linear function, and you got that. Well, this is a machine. You throw things in it. You throw things in here, and you're gonna come up with something. So for example, x. Since this is a linear equation, we're gonna give 3 negative values and 3 positive values, okay? So 3 negative values. -3, -2, -1, 0, 1, 2, 3. I could have given any other values, it really doesn't matter, okay? The idea is for you to put these values in there and get your output. Input, and then this is your output. So let's see. Your machine is called 2x minus 4. Okay. So when I put -3 into the machine, then this becomes 2 times -3 minus 4. When I put -2 into the machine, then you get 2 times -2 minus 4. When you put -1 on the machine, you get 2 times -1 minus 4. 2 times 0 minus 4. 2 times 1 minus 4. 2 times 2 minus 4. 3 times 2. Oh, no, still 2. Sorry. 2 times 3 minus 4. Okay, now, and now all you gotta do is now get your y. How? The result from here. 2 times -3 is -6. Minus 4 is -10. 2 times -2 is -4. Minus 4 is -8. 2 times -1 is -2. Minus 4 is -6. Guess what? Since the numbers here are in order, then I see a pattern here. Okay, do you see what's going on? See the pattern? So I'm gonna do -8, -10, -8, -6, -4, -2, 0, because they go by 2s, and then 2. And of course I'm not lying. 2 times 3 is 6, minus 4 is 2. Then here you write the order pairs. -3, comma, -10. -2, comma, -8. -1, comma, -6. 0, comma, -4. 1, comma, -2. 2. 2, comma, 0. 3, comma, 2. See that? That's what you gotta do. Okay then. So now it's time to plot the points. So let's see. My first point is 3, comma, -3, comma, -10. Okay, so what I'm gonna do is I'm gonna go to, if I have a thingy, I'm gonna go to -3 here. Okay, 1, 1, 2, 3, and then I'm gonna go -10 means on the y means that I'm gonna go down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The point is right here. Right here. So that's -3, comma, -10. The next point is -2, comma, -8. Okay, -2, comma, -8. The next point is -1, comma, -6. So -1, okay, this is 0. So this is -1, comma, -6. Okay, now look at the direction of our line. I don't need the values anymore to know the behavior of this line. Look, it's going 2 up and 1 to the right. 2 up, 1 to the right. So the next point is going to be here, 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 here. See, I already went overboard with this. Last but not least, you take your ruler, okay, It's funny, I don't have a, oh yeah, I do have a ruler. Take your ruler and connect the points. That's it. You don't have to limit yourself to this or to this or to this. No, just connect them because it's a straight line. A line in geometry, remember, has no boundaries. It goes on infinitely. Now, what I wanted to notice is the following. I want you to notice the following. This behavior right here is called the slope